Today we're going to learn about characteristics of linear functions. So inside of your notebook, we'll have another page labeled for our table of contents, and I just put characteristics of linear functions. And for mine, it's on page 6, but your page may be just a little bit different. So let's go ahead and get started. So first of all, how exactly do I know whether a function or an equation is linear or not? Well, let's see. So if we pay special attention to our x's, then we'll find out. So over here, what can you tell between this x and this x? What's the difference between those two? So if you look further, let's go down to this x and this x. What's the difference? And our last one. So if you're saying that the difference is this little number or the exponent, then you're exactly right. So as we can see over here, all of our x's are to the power of 1. And as opposed to the other side, we have an x squared, an x cubed, another x squared here. We do have just one x here, but you still have this x squared. So if it's only to the power of 1, if that's all the x's that you have just to the power of 1, then we say that these are linear. Now if we have others that are over here, these are examples of nonlinear. So these are your quadratics and your cubics. So let's go ahead and look at this slope-intercept form. Let me just scoot it up. Okay. So my slope-intercept form, it's going to be y equals mx plus b. I'm pretty sure you've seen that before. And the way I can remember it is, well, right here, I have my slope, and this is my intercept. So that's why this form is called my slope-intercept form. So what exactly is a slope? Well, as you guys have seen in the morning, it's also known as our m, and it's going to be our rise over our run. So that's what our slope is. So the slope tells us the steepness of a line. And the y-intercept, well, that's exactly what it is. It's at the, it's where my graph crosses the y-axis. So wherever it crosses the y-axis, that's going to be my y-intercept. So for example, if I have a point right here at 1, and let's just say that my line looks something like this. Okay, so this is going to be my b, or my y-intercept. And the slant of the line, how steep it is, that's going to be my slope. So let's look at an example. Down here we have that our slope is 4 and that our y-intercept is -6. So let's go ahead and turn this into our slope-intercept form. So I'm always going to start out with y equals. I'm going to have my slope followed by an x followed by my y-intercept. Okay, so my slope is 4, so it's going to be 4x, and my y-intercept is -6. So be sure to pay special attention to whatever sign your slope is, because that's the sign that's going to go right here. So this is the equation of my line. So now let's graph it. So I always start at my y-intercept. So I'm going to put a point at -6, because that's my y-intercept. Let me just put this here. Okay. And now my slope tells me that it's 4. So if it's rise over run, and my slope is 4. I'm just gonna put a 1 over that. 4 over 1 is the same thing as 4. So I'm gonna rise 4 and run 1. And since my slope is positive, I'm going to rise and run in the positive direction. So I'm going to rise 4, 1, 2, 3, 4, and I'm going to run 1 in the positive direction. And that's where a point is gonna go. So I can't do my line just with 2 points, but let's just do it one more time just for practice. So I'm gonna rise 4, 1, 2, 3, 4, and I'm going to run 1. And if I connect all my points, then I'm going to get my line. So let's go ahead and practice this.